Hello, welcome to the design department. My name is Josiah. I'm a senior structural designer here. Here in the design center, we're responsible essentially for our structural design development and packaging innovation for the whole company. We work in a ton of different product categories. Anything that we're doing with paperboard folding cartons, rigid boxes, paper pulp trays, anything that can go in that, we can do. And we work basically anywhere from setting up a sample of a design that you already have to run on our machines to we need a custom box start to finish. We can work anywhere on that spectrum. So mostly we work in paperboard. This is an example of kind of a complex support structure, but we can do internal, external packaging, masks, cover cards, any sort of carton work we can do. We practice kind of making this board be as versatile as possible. So this is lots of non-standard structure making or bending established structures into shapes that do perhaps things that they weren't originally intended to do, but that we can make them a lot more functional. For example, this is just a straight tuck carton at its core, but it has a lot of extra functionality built in that we'll use to support different products within other forms of packaging, like a rigid box. This would be an example of something that is a structural innovation we can do. We're sort of inventing this shape and inventing these capabilities and making the paperboard do what we want it to do, rather than just following kind of a cookie cutter cutout of like, oh, make a straight tuck box. We can do anything from making that straight tuck box to inventing something new. We've got a few patented designs, so we have the capability to really innovate. So this is an example of a pulp tray. These look really nice inside of something like a rigid box, but this pulp is essentially a formed piece of paperboard fibers, where you have a screen mold where we set that screen mold down and suck water through it that has all sorts of paperboard fibers suspended to it. Afterwards, it'll go through a few stages of heating and pressing through a few layers of paired metal molds. And after this gets heated and pressed, you end up with this final shape, tailored to your product and fits very nicely inside of other forms of packaging, such as paperboard cartons or rigid packaging. Speaking of rigid packaging, something we also design and can make. A rigid box is like this, like a board game box or lots of high-end technology boxes. It's basically composed of two parts, what we call a chipboard inner or a chipboard skeleton. That's a sort of dense fiberboard that we use for the structure of the box. And the other part is a wrap, which is a fine paper that's easily printed, and we wrap it around the rigid chipboard underneath that gives it its nice finished look, its nice crisp edges, and we can do lots of things with these. We can make things like slip cases. We can make a box like this, which we would call a full telescoping rigid box. So we can also do some design and production work with corrugated. We'll typically use small flutes. E-flute, F-flute, N-flute are all thinner sheets of corrugated than you would imagine that from your standard brown box that you might get in the mail. But we'll make these corrugated nailers, which what we're essentially doing here is creating packaging that adds structure for whatever reason. This is a lot more likely to withstand the dynamics in a shipping environment, and so we can make mailers and things like this out of small flute corrugated, which is really nice. We can still print on it nicely. We can still emboss it if we need to. We also have the capability to design thermoform plastic trays. So these differ a bit in construction from our pulp trays. These are essentially, they start as a flat sheet of plastic where we will 3D print a prototype mold like this. We set this 3D printed prototype mold into a thermoforming machine, which heats up a sheet of plastic. And as that plastic gets heated up, we actually turn on a vacuum, which will draw this plastic down around the mold, and as it cools, you're actually left with this structured plastic tray. We have 4 full-time designers here with us. We use 2D CAD, 3D CAD. Our main softwares are ESCO's Artios CAD and Siemens Solid Edge for our 3D work. We also have 2 big zoomed sample cutting tables, as well as a SwissQ Impala flatbed printer. And we use all this for creating prototypes as we design, or creating samples for customer output. We also use this Stratasys F370 3D printer. It's just something we use for creating real prototypes of customer files if we get them. We also use it for printing molds for our thermoformed plastic prototypes, and we will also prototype our pulp trays directly on this. When it comes to what we can output and what we can send customers, on the ideation end, we can just draw up sketches that quickly communicate concepts. That way we can narrow in on the best idea kind of as fast as possible without taking the time to engineer and build out every single concept. From there, we can do designs, and we can apply real graphics to real structures and both output 3D renderings of those concepts with those graphics, or we can do real construction. We can send out plain samples of real engineered concepts, all the way to we can print and place graphics on those concepts. So we can send out fully printed, fully set up concepts of an entire prototype package. So we actually keep a very expansive and large inventory of stocks in our prototyping lab. And so what that allows us to do is prototype any given design on the stock it'll be manufactured on, which guarantees better fit and function. So anything from SBS, CNK, craft board, MPE coatings, hollow foil coatings, any of this stuff we can prototype your package on, and so we'll have a very, very close idea of how it's going to fit and work together with itself in manufacturing. I also do a lot of collaboration with both our sales and manufacturing teams. So, for example, we might collaborate with a sales team to offer technical and design support, offer ideas, offer feedback, potentially work with customers, explaining how we can solve problems and such. We will also work with our manufacturing teams to ensure that anything that we're designing and sending out as samples is manufacturable. We don't want to be sending out designs that it turns out, oh hey, sorry, we can't manufacture this. So we work really closely with our manufacturing teams.